Good afternoon and welcome to the fifth session of the 2017 Specific Learning Disability Math Webinar Series, Bridging the Arithmetic to Algebra Gap, presented by Dr. Brad Witzel. Thank you for joining us. My name is Jill Marshall and I am the Specific Learning Disability Specialist in the Exceptional Student Services Unit of the Colorado Department of Education. I will be your host today. For those of you who are joining the series for the first time today, welcome. And for those of you who have participated in the other webinars, thanks for sticking with us and welcome back. CDE is a dynamic service agency and has established a clear vision for increasing student performance. CDE continually supports the advancement and improvement of the state's education system to prepare all learners for success in a rapidly changing global workplace. Our vision is that all students will become educated and productive citizens, capable of succeeding in society, the workforce, and life. And our mission is to ensure that all students are prepared for this success by providing excellent leadership, service, and support to schools, districts, and communities across the state. One way the CDE is committed to ensuring the success of students is to provide leaders and educators professional learning opportunities that include evidence-based practices for literacy and numeracy instruction. The 2017 SLD Math Webinar Series has focused on a variety of evidence-based instructional practices to support students who struggle with mathematics. Here you can see the titles and topics that were covered in each of the webinars. Today is the final webinar of the series. Once captioned, all of the recorded webinars will be posted on the CDE SLD website, which is shown at the bottom of this slide. Please also visit the SLD website if you are interested in finding additional learning opportunities or joining the Colorado SLD listserv.
Before I introduce our speaker, I would quickly like to review some housekeeping issues and information about today's webinar. This is a recorded webinar and your microphones will not be activated during the webinar. Please sign into the chat box with your name, role, administrative unit or agency, and the grade levels you serve. Please type any questions you may have into the question and answer window or chat box, and we will address them as we are able during the presentation or at the end of the session. If you have difficulty accessing the webinar or have technical issues, please call Amanda Timmerman at 303-866-6969 or email her at timmerman_a@cde.state.co.us or contact Jill Marshall at marshall_j@cde.state.co.us. Please also feel free to email us after the webinar with any additional questions you may have.
There will be a brief event evaluation survey at the end of this webinar. The link will be provided on the last slide of this presentation. After you complete the evaluation survey, your certificate of attendance for one CDE training hour will open automatically. Please print your certificate for your records. The recording of this webinar will be made available to participants in the future. Please contact me, Jill Marshall, or Amanda Timmerman for viewing requests. And once again, I have the honor of introducing our presenter, Dr. Brad Witzel. Dr. Witzel is an award-winning teacher, professor, author, and professional developer. He has delivered over 400 international, national, state, district, and school presentations, as well as developed a dozen educational videos. Dr. Witzel has authored 9 books, 8 book chapters, and over 30 research and practitioner articles. He is a governing board member of the Southeast Regional Educational Laboratory, funded by the Institute of Education Sciences, and a member of multiple state-level MTSS and RTI governing boards. Dr. Witzel serves as the editor of Focus on Inclusive Education through the Association of Childhood Education International, and served as an author panelist on the IES Practice Guide, Assisting Students Struggling with Mathematics, and as an invited reviewer with the National Mathematics Advisory Panel. Most importantly, he is a father of two, husband of an educator, and son of two educators. I am grateful to have been able to work with Dr. Witzel and to bring the webinar series to Colorado. Dr. Witzel, thank you so much. I'm sad that this is our final webinar together, but thank you for all of the knowledge you have imparted, and I'm very excited to learn even more today. Welcome back, and take it away.
Hello again, everybody. This is Dr. Brad Witzel from Winthrop University. And believe it or not, this is the fifth and final webinar of our series. This time, Bridging the Arithmetic to Algebra Gap. Got to tell you, as a former high school teacher, I think I put a little bit too much into this one. So I hope that I won't overwhelm you with the ideas here. But at the same time, it's not a bad idea to go back and review some of the strategies that we cover. So why cover STEM? Well, one, we do know that's where the jobs are. But we also know that this is where a lot of the future growth is in our economy. As I put in there, it's not that there are no jobs for people who graduate right now. It's that these seem to be the jobs and fields that Americans simply don't study. Civil rights leader Bob Moses, when he put together the Algebra Project, or what was also known as the Harlem Project, tried helping students who were told that they'll never succeed in math, and he focused their curriculum on mathematics. Now, some people say that he had mixed results in it, but I got to tell you, he turned around the lives of a lot of families by focusing on an area of study that usually people don't do in this country. You got it, mathematics. The same can be done for students with disabilities. So take a look at what algebra has become. Yeah, anybody been around long enough when algebra was one single course? You just took algebra and then you moved on to trigonometry and geometry. Well, that's where this started. Along the way, though, we said, you know what, there's more to algebra, though. That pre-calc thing's coming along. How about algebra mixed with algebra 2 and trig to come a little bit later? Then later on, they said, you know what, scores still aren't moving. Our scores in algebra stay the same. So let's take out the trig. We'll call that pre-calculus. And we'll just put together algebra, then algebra 2. Then we said, well, I don't think kids are ready for algebra. Let's put in there a course called pre-algebra, then they'll take algebra, then they'll take geometry, then algebra 2. Still, the scores weren't moving. So what do? Well, we decided to go to kindergarten children, and we'll just say the word algebra a lot to them. And if we say the words algebra, they'll be more comfortable with it. Then we give them pre-algebra, then algebra 2. Of course, very little movement. So I know what we're going to do. We're going to talk about algebra the whole way up. Then when we get to that middle school level, we'll start putting pre-algebra all across middle school. So by the time they're in 8th, if they're advanced, or 9th grade, then they'll take algebra 1, and then they'll take algebra 2 later. Still no movement in scores. So next step, you got it. Let's talk about algebra in elementary. Then we'll do pre-algebra. We'll be getting them ready for it. Then they'll take Algebra 1, Part 1 for one course. The next year they'll take Algebra 1, Part 2, and then they'll take Algebra 2. We've had a little growth, but not much. Where are we at now? Well, now we're doing about the same thing, but we're starting to change the titles of them because we've had such little success in pre-algebra and getting ready for it. We're starting to throw algebra at students real early and hoping that, well, if they don't get it now, we'll just repeat it for them and take it once, then twice. Well, why all this push for algebra, which was one single course to start out with? Well, take a look at some of the research here. I'm going to work my way from the bottom up. Edelman was going through some of the research on algebra, and he found that for when we get to college levels, he said, you know what? Post-secondary fields seem to be very math-related. But we're finding out that students are coming into college not prepared to take the math courses in college. So his assumption was that we no longer have an algebra need, we have an algebra 2 need. Because of this watered down effect that we just went through, students were not taking the same level of rigor in algebra that they used to be because we'd watered it down so much because we spread it out. Warren Shulock did a review of research because I found a massive amount of dropout in California Community College. And what was most of the dropout related to? Yeah, you got it. Math. they're finding out that the average students coming in was actually 2 years behind in mathematics. You got it. In other words, they have to take 2 math courses when they reach community college just in order to receive a math credit, right, to get to that course. And so we're finding out that math ends up being the big barrier. And it's not algebra, it's Algebra 2 has become the barrier. So the new focus is not getting these kids that succeeding in algebra in our school, it's that they have to understand and be able to apply Algebra 2 by the time they leave high school. And that's just to get a technical degree. So what about students who have to repeat the same course? Well, in a large study in California, almost half the students who were part of a study had to repeat algebra because of low performance. Of them, after the second time they took algebra, over a fifth of them did better and met proficiency that second time around. Now, that looks like an okay result of this, but truthfully, that's not a fantastic result. And when we look closer, we found that the high-performing students, when they repeated algebra, they actually confused concepts from the first time they took it to the second. However, the low-performing students tended to do better. It ended up being that the students with disabilities and at-risk concerns did better when they repeated algebra, getting a double dose of it, rather than the high-performing students or higher-performing students. So let's talk about our series of webinars. The first time we got together was in February, where we discussed students who have attention and memory concerns, and we talked about some instructional strategies to help them out. That's where we started this. We then took that idea and we moved it on to whole number operations. We talked about place value, fact fluency, and multi-digit arithmetic. In April, we took the idea of multi-digit arithmetic and moved it to rational numbers. We started showing more number line approaches. We worked through integers, fractions, decimals, ratios, and percents. Then, in a lengthy discussion, we talked about the language of mathematics. We talked about vocabulary, problem solving, and of course, we got into schema-based problem solving, one of the more powerful strategies out there for solving word problems. Today, one of the most exciting, we're going to have all of these will lead up to this one today. It's what to do to get students ready for algebra, and then what do we do to help them access algebra once they're there. To guide us today, there's 2 of the books that I recently had the opportunities to write. One is the elementary strategies, which is the preparation, and then more specifically in preparing for Algebra 2 is bridging the gap between arithmetic and algebra by the Council for Exceptional Children. Now, within today, we're going to grab strategies from each one of these books, but we'll even extend beyond those. The focus will be on what we need to focus on for the instruction, what areas of mathematics, and then we'll even include some instructional strategies based on the students who have intense learning needs. So the question is, can we predict success with algebra? And the answer is, well, yeah, to an extent. We're starting to get better data of what to do in preparation for it. In other words, what is it about early childhood learning that builds up through early middle school, late elementary, and then how does that prep for Algebra 1? And hopefully we'll start getting some results in how do we get ready for Algebra 2. Take a look at these 2 math expressions. Try to simplify them. On the left, you have 2 binomials. On the right, you have a complex fraction with a quadratic in there. If you're watching this in a recorded session, you can press pause here and solve them and decide what math is needed in order to simplify these expressions. If you're live with me, we're going to run through it. Start with the left. If you know the distributive property, right, y times y plus y times 2 minus 5 times y minus 5 times 2. And then, so you have to know your multiplication, have to understand how exponents work, combining like terms, and even maybe some negative numbers. How about this complex fraction on the right? What would you need here? Well, I got excited and I threw out the quadratic equation, which meant you'd have to understand the formula. You have to understand powers, negative numbers, order of operations, division, fractions in that division, how to convert, right, equations to solutions, and then even the property of identity. So there is some complex mathematics going on here. But even despite the what appears to be very hard problems, we're really not pushing more than 6th or 7th grade mathematics on it. Mathematics gets really compressed when it gets to algebra. It's not that new wild things are happening. It's that we have to make sense of what we see in front of us. Algebra is trying to explain arithmetic. And that's what we're trying to get to. It's the arithmetic to algebra gap. So what do algebra teachers say? In the National Survey of Algebra Teachers about a decade ago, most algebra teachers thought that students were weak when it comes to rational numbers, of course applications, and like all high school teachers and middle school teachers, study habits, of course, right? But when we ask, what do they need to really help these kids prepare? Better elementary mathematical concepts and skills. In other words, understanding fractions, decimals, ratios, percents, fact fluency, and automaticity. But they also responded with some other ideas. And some follow-up questions with them. They had lots to say about how they teach and use of calculators and groupings, and we've discussed some of these. But look at this fourth bullet. The greatest challenge to teachers for both middle school and high school was working with unmotivated students. Because when the students start getting to algebra and beyond, how many of them already been told by their parents they'll never see this stuff? This stuff isn't important to you. Which is really sad because the job market has really been pushing this. So we can actually open the door for students to get new work, to get job opportunities if we can get them through this mathematics. The next most important or most frequent response we got was making math accessible and comprehensible to all students. That's what we're going to try to focus on here today. Take a look at some of the nation's report card. This is 2015 results here. Whenever you look at NAEP results or National Assessment of Educational Progress, from the bottom up, there's a below basic, which means students are severely behind. There's then a basic level. Basic's not great. It means that they can barely understand the grade level. And we're going to move them on, but they're probably not fully ready to move on. They'll need some intervention support. And then there's proficient, which means they understood the grade level. And then there's advanced, which means they're working beyond expectation. Look at these scores here. For mathematics in 4th and 5th grade, which means proficient and advanced, 40% of our students by 4th grade were proficient or advanced. It drops down though. As math becomes a little harder, fewer students are proficient or advanced. Same thing holds in reading. About 36% were proficient or advanced, and a small drop. Where we had a larger drop in math, we have a small drop when it comes to reading from 4th to 8th grade. But take a look at the abysmal scores of students with disabilities. Only 16% of them were proficient or advanced by 4th grade, down to 8% by 8th grade. Half of them. Reading had a drop, but nowhere near the mathematical drop. Well, that's for the students who are performing at or above grade level, or beyond expectations, I should say. What about the students who are performing very low in mathematics? Well, take a look at this one. The national, overall, 18% were below basic by 4th grade, and it got to over a quarter of our students were below basic by 8th grade. In other words, the students who started weak, continued weak, and stayed weak, and then more students joined them who were probably on the bubble earlier. Reading's actually the opposite. 31%, which is a much larger group, who struggled in 4th grade. Few of them are actually getting above into the basic and above when it comes to 8th grade. In other words, we're seeing improvements in reading across grade levels. And math is different. More kids struggle. Look at the kids with disabilities. 45, almost half of the students are below basic in 4th grade, and over 2/3 of them are below basic in 8th grade. Now the reading scores look pretty bad too, but again, look at the score differences. Where more students, as grade levels increase in complexity, more students struggle in math. While in literacy and reading, you got it. You actually see more students getting turned around. In other words, interventions beyond 4th grade are working for students in reading, but maybe not so the same way in mathematics. Math is a different approach. Math continues to grow on itself and get more and more complex. Literacy has a cap effect. Math has no cap effect. So I ask you, what does that mean to your interventions? Does that mean you should focus more on Tier 2 and Tier 3 in math? Does that mean math intervention should occur more during the core instruction? That's for you and your teams to decide, what are we going to do to turn around these kids in mathematics when maybe these isolated interventions are not nearly as powerful as they are typically in reading. It's called the arithmetic to algebra gap. It means that students who are unsuccessful in arithmetic will tend to be unsuccessful in algebra, requiring more intervention. However, success in arithmetic is necessary but not sufficient to success in algebra. Some kids who are successful in arithmetic continue on to be successful in algebra. However, some who appear successful in arithmetic never quite understood conceptual ideas or mastered some basic foundational skills, and thus they fall apart when they get to algebra, requiring more intervention support. Our goal is to set them up so they're successful in arithmetic, and we make the success such that it prepares them for understanding Algebra 1 and Algebra 2 concepts. Well, don't worry, we've already started on this. The Council for Exceptional Children asked me a while back to put together some of the top math people in the country and decide, what are we going to do to get these kids ready for algebra? And take a look at it. We talk about some of the big ideas, core instruction, math progressions, we're going to cover that today, computation, fractions, problem solving. These are things we've talked about as a group already through the webinars. And today, not only will we talk about some of these progressions and core math ideas, the big ideas, we're going to also talk about what do we do to help kids access algebra who may really have struggled in arithmetic. So here's the agenda. We're going to start out with the key math areas for development. What are the major areas of mathematics that must be understood and covered early? We're then going to get into the progressions and how do we set kids up long-term for success in Algebra 2. And then finally, we'll end up with 4 strategies that will help students. And these strategies are of increasing intensity, such that cognitive strategies is a low intensity, a little more intense is these fully worked problems, a little more intense is field dependent, and finally the most intense is a visual representations or the concrete to representation to abstract sequence of instruction. Let's get started. Well, me and my team were a little curious of how well were students doing in middle school. So we gave them the Algebra Readiness Test at the end of 6th grade and at the end of 7th. The Algebra Readiness Test covered them in data probability, equation solving, decimals, exponents, fractions, computation, graphing, and integers. And look at this. No effect, not significant, no effect, not significant, no effect, no effect. Significant growth in data and probability. It's an applications approach. But look, no effects, minimal, minimal, no effects, no effects, no effects. In other words, the weaknesses of students with disabilities when they walk into middle school. There are so many gaps in their skills already, they're having a hard time accessing middle school content in order to understand and get ready for algebra. So we've got to have planned and direct intervention support on key areas to prepare kids for algebra understanding and success. I suggest you can do this with your own team. I'll give you some of our general findings, but here's what you can do with multiple grade level teams. Get some sticky notes and line up some cards from K to Algebra 2 and have every teacher write down what did students walk into your class with not knowing that they should have already learned. Now, you're going to start seeing some repeats. For me, I saw a lot of fractions. When I did this, even getting up through college, and we bring in a community college group that's in a small town locally, we can even get up through where the multiplication skills, where the 4th grade teachers said they lacked, they end up lacking it the whole way through. But it's really interesting to do this error pattern analysis to get this common themes built up. But I want to share with you what we have found before you do this on your own. Let me give you some ideas of what we have found. I want to work backwards a bit. My middle school groups, and you'll see very similar things for the high school groups, my middle school groups came up with these ideas. Expressions and equations, ratios, proportions, of course computation of rational numbers, linear algebra and linear equations, and then of course some geometry. Now, why would they struggle with these areas? Well, take a look at the 3rd to 5th grade group. If you're going to struggle with computation of integers and fractions, you probably struggled with, you got it, whole number operations. And if you struggle with making sense of different ideas such as geometry, there's some problem solving going on. And if you had problems with whole number operations, you probably can't problem solve with it. And if you had problems computing decimals and fractions, you probably didn't get the concept of decimals and fractions. Same thing with long division, which combines multiple skills. So one set of problems leads to the next. Let's go backwards again. If these are the main areas that came out for the 3rd to 5th grade, what do you think the K2 group said? Right? There's no magic. There's no one to blame here. They're saying when they come to us, they don't know their numbers. They don't understand quantities and magnitude. They certainly can't understand place value. They don't even know what the numbers say. They're counting. They're basic facts, addition, subtraction. They can't even begin to understand how to connect it to data and patterns and geometry and measurement. And if you're looking for this Fry reference, you can look up IES Practice Guide Fry, and you'll get a lot of these ideas and concepts of how to teach early number sense to students. We covered that a couple of months back. My point here is a weakness early in mathematics doesn't go away as time goes on. It just becomes a bigger problem and affects more and more areas of mathematics. So what can we do about it? Well, let's talk about some progressions in queuing. The cat's going to lead us into it. You got it. So let's jump into that bag. Now, let me explain what a scaffold and progressions are. A progression means that I am introducing an instructional approach in one grade level, and that same approach can be used vertically, grade level after grade level after grade level. A scope and sequence is a little different, right? A scope and sequence is something where we know the standards align and they build on each other. And some standards start fading out and other ones keep building on each other the whole way through K-12. A progression is a way to teach to that standard so that it builds on it. Now, there's lots of different ways to do progressions. We've done number lines together. We could do fraction triangles and computational triangles to make number line connections along with it and make those connections a computation. I'm going to focus on place value and how to use place value into array models. So to start out with, you have to know place value language. Earlier on, we talked about how to take 74 plus 28 and use the place value language so that it's 7 tens, 4 ones, 2 tens, 8 ones. So let's add them up, and I wrote it out here so you can see the language behind it. What is 7 tens plus 2 tens? Well, that would be 9 tens. Take a look. What's 4 ones plus 8 ones? That would be 12 ones. So what does 12 ones mean? Well, it means 1 10 and 2 ones. So how many tens do we have now? We have 10 tens, or 100, and 2 ones. The answer? 102. So that kind of language system, you're not doing that to make a better multi-digit addition answer. You're doing that so you can set up future learning. What does that mean? Well, so take a look at how this builds into an array model. We're going to take 7 tens, 4 ones times 2 tens, 8 ones, and we'll set it up as an array, as we did when we covered whole numbers. 7 tens times 2 ones, 7 times 2 is 14, 10 times 10 is 100. The answer, 1400. What about 4 ones times 2 tens? Well, 4 times 2 is 8, ones times tens is tens. 7 tens times 8 ones. 7 times 8 is 56, 10 times 1 is tens. The answer, 56 tens. How about 4 ones times 8 ones? Well, 4 times 8 is 32, 1 times 1 is 1s. Then what do we have to do? You got it, it's a partial products piece, so you add them up. You add up the number of hundreds, the number of tens, and the number of ones, and then you break it down. Well, again, the purpose of this is not to find the best way to teach multi-digit multiplication. We're getting ready for the next step. When it comes to decimals, we all tend to say these correct. We've already learned not to say 3.4 times 2.8. In whole numbers, we're still learning to say those correctly. But in decimals, we've all caught on that it's 3 and 4 tenths times 2 and 8 tenths. So let's go through them. What's 3 ones times 2 ones? Well, the answer is 6 ones. How about 4 tenths times 2 ones? Well, 4 times 2 is 8. Tenths times ones is tenths. The answer, 8 tenths. How about 3 ones times 8 tenths? Well, 3 times 8 is 24. Ones times tenths is, you got it, tenths. The answer, 24 tenths. How about 4 tenths times 8 tenths? Well, 4 times 8 is 32. Tenths times tenths is hundredths. The answer? 32 hundredths. And then we add up the number of, you got it, ones, tenths, and hundredths. Now, seems like a pretty logical piece, but you might be saying, boy, wouldn't it be easier if they just moved the decimal? Well, we're trying to get to a sequence of where this goes progression-wise. Take a look at what happens when we get away from a base 10 approach and we start getting into fractions, which, right, changes bases on us. 6 and 1/2 times 7 and 1/3. What's 6 ones times 7 ones? Well, that'd be 42 ones. How about 1/2 times 7 ones? Well, 1 times 7 is 7. Halves times ones is halves. The answer, 7 halves. How about 6 ones times 1/3? Well, 6 times 1 is 6. Ones times thirds is thirds. The answer, 6 thirds. How about 1/2 times 1/3? Well, 1 times 1 is 1. Halves times thirds is sixths. And that language system helps build that multiplication process there. What do we do now? We add them all up, which is easier said than done since we're adding fractions with unlike denominators. Right, but I want to show where this goes to algebra. Look at these binomials here. The quantity x plus 4 times x minus 3. So we split them up. And here's where we talked about the purpose of algebra is to explain the arithmetic. 1 times x and 1 times x. So it's 1x times 1x. What's 1 times 1? 1. That means xx is x squared. What happens if these were tens? It'd be 110 times 110. 1 times 1 is 1. 10 times 10 is 100. That 10 times 10 is really 10 to the power of 2. That's the same thing as explaining x to the power of 2. It's the same approach. So let's keep going here. 4 ones times 1x. 4 times 1 is 4. Ones times x is x. What's 1x times negative 3? Well, negative 3 times 1 is negative 3. Ones times x is x. What's 4 ones times negative 3 ones? Well, it'd be negative 12 ones. And you got it. We add them up. So we're adding up the x squareds, the number of x's, and the number of the constant, negative 12. So in this case, we see that there's a logical approach, and it started as early as multi-digit multiplication using an array model, because all the array model is doing is consistently showing you how to do the distributive property. Well, binomials is nice, but how about large polynomials? Well, guess what? We don't need to go through it all, but it works the same way, right? I'll just jump through this part. X squared times 2x squared. 2 times 1 is 2. X squared times x squared is x to the 4th. And the same thing goes over through the whole part. Now, I don't need to read all this to you, but please don't hesitate when you watch this separately to press pause and read through it. Read through the language of how it builds on itself. The purpose is not to make early on in 2nd grade and 3rd grade when you teach place value. You're not trying to make the best 3rd grade or 4th grade kid in the world. You're trying to prep him so that he can be successful in Algebra 2 and beyond. The array model is one of the many progressions that can help do that. So what's the idea here? The big idea is here, avoid the tricks early that only help with a small number of items. Teach specific things that you know can be progressed on. I can give you a fun story. I have a kid named Josh who came to me in the 4th grade, and his parents also worked at Winthrop University, and they said, help, Josh has a learning disability and he's really struggling in mathematics, hates math. Will you tutor him? And I said, sure, but you got to understand, I'm not going to tutor him in 4th grade math. And they looked at me confused. They said, I'm not trying to build a great 4th grade kid. I'm trying to help him get up through Algebra 2. Just Algebra 2. Kid had a very high IQ, so make sure we understand that at the same time if you believe in any IQ things. But a supportive home life, wants to do well at academics, but just at this point hates math because he's struggling. When he came to me in 4th grade, I didn't just talk about how simple introduction to decimals worked. I started opening up things in 7th grade and 8th grade. And then I talked about the progression of what happens then and how to set him up when I'm tutoring him. So the tutoring session was never covering his homework or teaching him homework. I was prepping him on what's going to happen in mathematics and what he's doing today and how it's going to build on the future. Well, to make a short story, not so long like I like to do, right? It's always the opposite with me. what ends up happening? Well, he starts understanding math and starts liking it a little bit more. This year, he just finished up his 3rd year at MIT studying nuclear engineering. Now, again, that wasn't all me, but the purpose of what I'm trying to show is don't give up and let the kids see where math is going. You don't have to get bogged down by today's issue and never get to see the future. We can show where the mathematics is going, but avoid those tricks, help the child see beyond one grade level band, and focus on the future. That's a tier 1 approach. Okay, with the remaining time here, let's try to get some of this time spent in these at least 4 different areas of secondary math concepts. As I stated earlier, we could spend days on each one of these. So please don't hesitate to press pause or go back and try on your own to make sense of each one of them, because I am going to have to go through them pretty quickly. But I don't want to leave you with just 1 or 2 strategies. I want you to have a choice of which ones you can go into. And as I stated earlier, these are in growing intensity. A low intensity intervention would be cognitive strategies. A little more of these interleave fully worked problems. A little more intense is field dependent, and more intense than that even are these visual representations. Let's get started. Now, I guess one hesitation to me getting started is I'm not alone in this exercise of trying to help students learn algebra. At the core level, the U.S. Department of Ed has put together an IES practice guide, on how to help students in middle school and high school algebra. And the team came up with 3 major ideas. One idea was to solve fully worked problems. Let kids see fully worked problems. Another one, help them see lots of visuals so they understand the structure of math, progressions as well. And this third one is, let students, it says choose, but they get smarter than choose in the explanation. If you're going to show a child more than one way to solve a problem, don't introduce a child with memory problems 2 different ways to solve them. Teach them the most efficient way first, and if the student understands that most efficient way, you can show them an alternative algorithm, but then force the child to learn why the 2 approaches are similar mathematically. If you show a child 2 different ways to solve a problem, they're not going to always understand when to use which one. So show the mathematical connections between them. I wish we had more time to really get into that framework of thought of how to differentiate learning. But again, that's one. Please, when you see these effect sizes, don't get turned off by minimal effect size, moderate effect size. When it comes to research and meta-analyses, they don't mean that these are bad. What it means is that we don't have enough research to really go through a lot of replication studies. There certainly aren't enough studies on algebra in the United States. We typically have to turn a lot to international audiences to get those studies. Well, to mirror some of their work, Elizabeth Hughes out of Penn State got to work with me and some others to show some of the better algebra interventions that we see in research for students with disabilities and at-risk concerns. Here's what we found. One of the less intensive ones we're about to show is cognitive strategies, and that has really worked. A more intense one is that CRA approach that we'll show at the end. So along with John Starr's work, we've got some meta-analytic work that also confirms what we're showing you today has got some good research support. So let's dive into it. Let's start at the strategy-based piece. I'm going to show you a cute little cue, and I'm going to see if you can connect it to what it meant. Ready? Let's start it out. King Henry died by drinking chocolate milk. All right, what are you thinking here? Anybody remember this one? It's the metric system. You got it. All right, let's try another one. Get ready? Here we go. Please excuse my dear Aunt Sally. Too easy? Yeah, you're probably not even saying all these words. You're probably saying PEMDAS, right? And please notice that I can combine multiplication, division, addition, subtraction, right? They don't need to be separated here. But you got it, the order of operations. Show at least one more here. Dad, mom, sister, brother, rover. I didn't know this one. Anybody know this one? I can see your hands out there. I know you can't hold back. Long division. I made bring down one word. I don't know. But anyway, I had to make it fit. Divide, multiply, subtract, bring down, repeat. These are strategies. These are cueing systems here, acrostics and mnemonics that students see when they go, oh, here's how I solve this kind of problem. You probably have seen some of these before. the commutative property comes through commas, right? Simple word problems or simple, even just doing simple calculations goes to the draw. There's many out there. What me and my team decided to do is create some of ours just for, well, middle school and high school level. Take a look. Because I like to introduce too much at once, I should have these fly in, but I'm doing this late at night. I might get confused. On the left side here, take a look at solving equations. What we did is we task analyzed how we solve equations, and we came up with a couple steps. We did what's called a first word mnemonic strategy. We created it so we had, typically you want a verb to lead it out, and you want that verb all to start out with the same type of letters that lead into something to help a kid remember it. So we thought when you solve equations, you should isolate the variable. So when we isolate the variable, here's the steps. Identify all the variables in the equation, set up the equations, right? It's that balancing piece. Organize it to balance, which means you are subtracting x from each side or subtracting the constant from each side. And then let equations begin. That just means calculate. Add the variable side to the equal sign, total the other side, and then evaluate and check. Not the greatest mnemonic, but it helps a kid walk through of what he should do every single time, ISOLATE, and go through how to solve equations. In time, go back through and see what we did for slope-intercept, for rise-run, for how to use a slope-intercept form to graph, or one of my favorites here, an oversimplified way of doing quadratics. We did this for kids who struggled with the quadratic equation. We found that the word factor, and we worked out how they should factor the quadratic. And again, very simple steps that we did when we task analyzed how to approach a quadratic. So these are some of ours. My question is, which algorithms can you turn into a mnemonic? Or, better question, which ones have you turned into a mnemonic? If you're doing this live, write them down in that sidebar, and let's do that in the chat log. If you think of this later, please email me. I do believe we got to share these things to help our kids get through. So email me, and I'll promise to use it in future events so more people can get the word out, and I'll put your name on it. But let's share these ideas with each other. So that was a less intense way, those mnemonic strategies. Let's get a little bit more intense here. This is called interleave. So I'll give you a little story about my growing up. I would go home with an Algebra 2 problem, and I struggled. And I'd be working at homework, and my dad would say, "Hey, you need help?" And of course, I'd reluctantly say, "Yeah, I need some help." So he'd take me to the baseboard and pull out the old blackboard or eventually a whiteboard, and he'd go through the work with me. And then in the middle of the work, you know what he'd do? He would check the back of my book and check the odd problems to see if he was correct. And then he'd adjust it or say, "Oh, the back of the book's wrong." Anybody grow up with that? Maybe our dads went to the same school of tutoring. But what we found is that not every question that you assign for homework has an example in the book. That's the first part. If you're crazy and you assign like 1 through 43, the evens, first, that's awful. Now they have nothing to check. But even if you go 1 through 43, the odds, I can almost guarantee you by the time they get to the 30s, there is no example in that book that's going to show them how to do the work. Therefore, they need something else to turn to. So there's a study done that was comparing what happens when students get to analyze a fully worked problem versus just an answer. Well, they found if you teach the kid to analyze a fully worked problem and see what each step is and really learn how to do the work, they'll look at the whole problem set and really figure out what works and what doesn't. It makes it easier on the kid. So let's go through that. And here I wrote in here at least every third problem, but let's get more planful than that. This is a quickie example that one teacher sent me. What she said was, "I think I do that, and I'm not attacking because this is better than nothing. But look, what she's got here is she's assigned these inequalities for homework, and she's got number 1 and number 5 already done. That's an okay start, but I'd like to know, why did you shade in this side? Tell me what you did here. What's this 4 mean, right? And what does this -3 coefficient mean?" I'd love a little more detail of explaining what each part is going through here. So when we got this back from teachers, we decided, you know what, let's come up with a strategy to help guide how to make an interleave work sample. So as we were building this, John Starr and his team did the same thing, and they supported this work. They said, you know what, we've got to show kids how to solve this, the systems of equations. We got to show them how we get through systems of equations, and let the students go through and question what's happening and even how to verify it. So a good approach, again, not just that we found it through research, but this has been supported at the meta-analytic level as well. In other words, there's studies of studies on this. So now let me get to how to do interleave. Sorry about that. Interleave preparation. We chose Enter as a preparatory tool. 1, identify the key problem variations. So I, identify key problem variations. N, note the levels of complexity. T, transfer the key problems that have each variation and complexity onto another piece of paper. Maybe you found out the same thing I have. Anytime you do a worksheet or even a book, everything's jammed together. There's not enough room to actually do work on a worksheet. And if I just tell the kid we'll transfer it to another piece of paper, he spends so much time transferring the problem, sometimes even incorrectly, it's a mess. So I like to transfer already a couple problems to another piece of paper, and I give lots of room to do your work. Okay, that's T. E, enter important examples that cover the variations and complexity. And then R, no matter what you're doing with this, every year you're going to learn by what you're doing and you're going to adjust the following. Right? No curriculum is ever set. If you ever seen a person teach it the same way year after year, they have not gained an experience. As John Dewey once said, he turned to a teacher who said, I've been doing it this way for 30 years. And so he said, so you basically have 1 year's experience repeated 30 times. Right? We know this. We've got to continue to grow every year. So here's an example we pulled out from a textbook. Take a look at this one. Holy cow, this was assigned to my daughter. And so we went, that's probably not exactly what we need. But we're going to do I first. And I is going to ask us, what are the key problem variations in here, right? And I see midpoint of a line segment, distance of coordinates, word problem here, geometry connections, and more midpoints with more complex ideas. This is midpoint and distance suddenly. Midpoint, distance, midpoint and distance. So I think we have some repetition in here. So identify the key problem variations, right? Like I said, midpoint, distance, right? And my crew from Star Trek, curious, but I think they agree. Now, what are the levels of complexity with that large problem set? If you're watching this not live, you can go back and look, but I'm going to sum it up here. Some of the problems involved whole numbers, but some of them you're probably going to trip over midpoint and distance because they involve integers and decimals and fractions and radicals. So guess what? We've got to have problems in there that have word problems, geometry, and a focus on whole numbers, integers, decimals, fractions, and radicals. So let's go back through this. Let's transfer it, right? So enter. T for transfer this key problem. So what we did, I'm a cheapskate. I took out the old scissors and cut out the main problems, and I simply taped these 5 problems to one side, and then I decided to group them up. And look, I even got my own typo that I did when I wrote the worksheet. Things happen. And I taped them on another piece of paper, on the other side of the paper. But take a look at the problems in here. I've got whole numbers, I've got integers, more integers, and to warm them up, and then we start getting into fractions and radicals. So we try to cover in, we of course have that one part in there. I didn't do geometry because we thought it extended beyond what the standard was calling for. Now, next step, E. E for enter important examples on the paper. We have the key problem variations that we thought would trip up our students, and we decided that that's what we're going to use, so we put those key problems in there. So now the students have fully worked problems that they can refer to when solving them. And we took one of the most complex problems out there, and we have it fully worked so the students can analyze how we approach that problem. So this is one way to do this. And so that's what my new worksheet looks like. And I'll get probably better information off this worksheet than I would off that packed together piece of paper I was going to hand them. Finally, I'm going to run a report on them. I'm going to analyze their data. I'm going to look through and I'm going to grade each step of each problem. And I'm going to find out if they have multiple problems in one area, what does that mean? What happens if they have a problem number 35, right? How does that match up? So I will analyze how they're approaching the problems and reassess what to do the following year to help them get through this amount of work. So my challenge is to you. If you have the time and you're watching this not live, press pause and get through interleave. Take a look at this inequality worksheet where things are jammed together. What would you do? What are the key problems? What are the complexities in here? Which problems would you transfer? And which examples would you give? So go through it. You can even, if you want to pull out your own textbook, open up your own textbook and see, how am I going to make interleave work for me? All right, let's start extending beyond interleave. So let's get a little more intense. I'll talk about incomplete problems, where interleave gives you fully worked examples. How about partially worked examples? Now, partially worked examples, we're going to use Cramer's rule for systems of equations, right, which is use of matrices, which means I've got some of the problems answered, but then I've got some blanks to be done here. So what do? Well, we give them some cues. Heck, we could even give them some of the equations that will help solve it. That way the student is not working off a blank slate and going, oh shoot, what's Cramer's rule? No, we start set it up so the student goes, oh, so I need to do just these steps? You got it. So he fills them in. As time goes on, we can start taking out more and more until the student just has to do it independently. When you teach and provide incomplete problems, it means you're focusing on what the intervention is supposed to cover. You're not trying to cover everything all at once. You're just focusing on a little bit at a time. So let's talk about what that means. It's called field-dependent learning. It means that you're going to give students almost completely worked problems, like a fully worked problem, but you're going to have an incomplete step or two in there, and you're going to leave a step or two blank. And then the student has to fill it in. And as the student masters each step, you got it, more blanks until the student becomes independent. It's a scaffolding technique. Take a look at this one. We've got the expression 12a minus 7 times the quantity 6x minus 1a plus x. So what do we do here? Well, we set up, they've already calculated what is within the parentheses, but then we've got a blank here. And the student's got to figure out, how do I get from here to here? So the student goes through the steps and goes, okay, so I've got 19a, so something's happened here. Oh, I know what it is. The distributive property. So the student then fills in what they would think of the distributive property and writes out distributive property. Now, if they get that correct, maybe I take out another step and leave it blank until they become more independent. Let's look at another example here. This is one of my favorite teachers, Christy. And they're solving for x across an equal sign. So it's 15 minus 3x equals negative 4x plus 32. So what are they doing here? Well, this is a given, and she set them up, she gave them a given. Now, she uses a lot of colloquial language rather than properties. She's let's say, a more motivating teacher in that regard. So she said, when you have to solve a problem with variable on each side of the equation, move the little guy. So negative 3x and negative 4x, which one's smaller or which one's more to the left on a number line? Negative 4x. So you add 4x to each side, and you get 15 plus 1x equals 32. Now we got to get from here to here. What happened? Wait, I got x on its own side and isolate the variable, right? I've got constants on the other. So how'd I get there? Well, in her words, you move those naked numbers to the other side. But what it would be is subtract 15 from each side, right? You're trying to reduce the constants. So this case, it's an identity principle, same thing. But now the student is going through and trying to analyze what step is missing. If I'm an interventionist and I'm working along a core classroom teacher, the core classroom teacher might be going through and teaching at this point, right, how to solve single variable equations when the variable's on each side of the equation. But my job is I'm working on addition subtraction. I'm trying to work maybe even on integer calculation, which means I will set up problems and leave the blank, and that blank is the intervention that I'm focused on at the time. So if it's a fraction that they're working on, I'm going to set up a problem and I'm going to do everything's all set up except the fraction. This way, my intervention matches what the core is doing, rather than it being some isolated idea. This leads us to an idea with field dependent of making a more intense field dependent approach. It's called a help strategy. You're going to focus on the mathematics area that we need. We're then going to run an error pattern to find out what's the missing area that my kids need help in. And I'm going to limit the lesson to that area. I'm going to let them perform the work and explain their stepwise reasoning. Never just let them write it through. I'm going to have them explain it, and then I'm going to scaffold the steps until they become independent. So take a look. I got a bunch of cards, and in this case, it's matrices, and I'm a big cheater. I took my textbook, I made a copy of it, and I cut it all out. So I got all my steps for matrices here, and what does the student have to do? They have to put it in order. Now I'm going to ask what are the steps, and my student will say, well, that was substitution. You can tell how old this was. I've done this a couple decades ago. But student says, okay, that's substitution for x plus z. And then what happened there? Well, the definition of matrix addition, right? Negative 21, a plus a, right? And 14. And then what do you have to do? Well, you simplify each step of the matrix. So I want the student not just to put these in order, they've got to explain why they put them in that order. This is called a help strategy, and you can get very complex with it. So let's get a little more systematic. I chose an easier example rather than matrices. I chose order of operations. So I've got a bunch of cards with the order of operations, and the students take the order of operations, all the cards, and what do they have to do? They have to put them in order and explain it back to me. Okay, so they explain it back of what happened. What's my next step? Well, I take out some of those already made answers and I leave in some blank cards. And what do I have to do? They have to put them in order and fill in the blank. You got it. What's my next step? Right? My next step is you give them more blanks, so they have to be able to put them all in order and fill in the extra blanks in there. Eventually, all the student has are blanks, or maybe even no cards at all. But eventually, the student just has to put them in order and then write out the answers. What, of course, I want the student to be able to do is not have any cards at all and just have this expression up top, and I have to tell them, right, evaluate that expression and simplify it for me. So this is one minute of the many ways to do this, but you take 3x5 cards and cut them in itty bitty bits and let the students organize it and explain the reasoning back to you. This is a friend of mine, Jim, who did this, and you can see not only did he set up these equations with all the steps, he put in a lot of, well, non-examples in here. He wanted to see that if you start this equation, and I don't remember which one is the right one he did here. This is just me sorting through all the cards on his desk. Jim's a master teacher and did this longer than I have. So if it's 14x equals 28, as you see here, right? He's got some non-examples in there that he wants to see. Do you think it's only a negative? No. So what should happen next? So he's got ideas that you would put in order, and he does interventions 1 on 4, 1 on 5. So he sits at this big table with students, work these through, and they're telling, right? They're telling their teacher what they did and how and why they put them in order. And in time, you start flip them over, make them so they can check and they can flip it back. But flip these over so they have some blanks and they have to write them as they go. So not the first to do this. My challenge to you, try a help strategy. Choose a hard, multi-level step. Task analyze what you want them to do. And don't just have the procedures in there, have the reasoning as well. Make them put them in order and explain the reasoning back to you. And then fade those steps. Try that once or twice and then tell me how it goes. I want to see how your students progress. We have found our more reluctant students tend to try harder with a help strategy than they would if you just give them an equation and say good luck. Okay, this takes us to a real brief introduction to one of my favorite strategies, a strategy that in several states I'll spend weeks just doing this strategy, and we'll focus on this strategy on a K Algebra 2 level. It's called CRA. CRA stands for the concrete to representation to abstract sequence of instruction. If you've partied with us all throughout these webinars, we've done several CRA lessons. Some you see live demo, some we've shown you video clips of it. In this case, to catch you back up, I provided you 2 websites where you can go watch some videos of CRA. I heard there's even some YouTubes that I think RTI TLC made, and you can watch a YouTuber or 3 of me going through some fractions. But CRA is an intensive intervention because it requires so much prep. The only reason why we're just throwing it at the end, it's intense and it requires a lot of prep. It will require you to think more complex approaches to mathematics. I'm going to do a kind of simplified one, and one that I don't know if I love, but it is possible. This is using base 10 blocks to multiply two binomials. Now, why I said I'm a little skeptical of this is for 3x, I don't know if I love having x, x, x next to each other. Right? X, x, x is not 3x. X, x, x is x cubed. But I have to keep in mind that these are typically done within an array model. And in an array model, there's an applied addition in between each one of these increments. So it's 2x plus 2. So that'd be x plus 1 plus 1. X plus x plus x plus 1 plus 1 plus 1 plus 1. Oh, I think plus 1. One more. So we set this up as 3x plus 5 times 2x plus 2. And we have to make a rectangle out of it. So what's 3x times 2x? Well, 3 times 2 is 6. X times x is x squared. How about what's 2x times 5? 2 times 5 is 10. 1 times x is x. 3x times 2. 3 times 2 is 6. 1 times x is x. And finally, 5 1s times 2 1s. 5 times 2 is 10. 1 times 1 is 1. So concretely, they would set up the array, and they'd say, how many x squareds do you see? I see 6. How many x's do you see? And they go 10, 11, 12, 13, 14, 15, 16. Okay, I see 16. And how many 1s do you see? I see 10. So what's my answer? You got it. 6x squared plus 16x plus 10. And we can even do different things to factor out, right, a 2 in there. But this is a concrete way that walks them through it and forces the language. The benefit of a CRA approach is it forces your abstract language. So this is a concrete way, and I'm going to break down in a representation way in a very simplistic form, one that you can probably even extend beyond. So hopefully we get the same answer, right? It's the same problem. But in this case, I've got x plus x plus x plus 5 1s, x plus x plus 2 1s. So I go through this and I set this up. What is 3x times 2x? And the answer, right? Well, there's 6x squareds. Well, how about 2x plus 5? Well, that would equal 10 x's. How about 3x plus 2? That'd be 6 more x's. And how about 5 1s times 2 1s? And that would be 10 1s. And you go through the same approach here that you did concretely. And usually when you do it concretely first, and there's some new research on video formats of concrete, but usually when you get through the concrete first, the student develops a language system so that when doing pictorial, they're really still thinking about the concrete level. The real goal of CRA is to be good here at the abstract level. So we go 3x plus 5 times 2x plus 2. And we've done this before. Hopefully now they're thinking of the x's, right? They're going, well, that would be x times x would be x squared. 1s times x is x. X times 1s is x. And 1s times 1s is 1s. And we get to the same answer. Now, CRA can be simple like this, or CRA can be more complex. This is one of the better models that we've come that's more robust. It covers larger areas of algebra. It doesn't hide the coefficient, right? There's one group of x. If it was 2, it'd be 2 cups with an x, right, for 2x. But the purpose of this, I want you to see in C, R, and A, CRA, it matches step by step. Whenever you plan out a concrete lesson, you're thinking, what are the abstract steps I need to get to? Whenever you plan a pictorial, you're thinking of the abstract steps. That way, you're no longer talking about cups and sticks. You're talking about the abstract notation. These are just tools to get there. If you're ever interested in learning more, please don't hesitate to contact me or my colleagues to set up a workshop or at least a discussion. So, I throw a lot at you for a last date. Here's what we did. We talked about the key areas. We talked about focusing on Algebra 2 and some of the research that we've had. We then shared a progression. We said there's really lots of progressions out there, but we focused on the array model today just so you could see the progression as it builds up from place value. We then covered 5 secondary math concepts. We did metacognitive strategies, real brief introduction to just the mnemonic approach. Then we did interleave, then we did help strategy, and finally we finished with some CRA. In my last minute here, you can press pause if you need. Think about what are 3 things you learned that are new? What are 2 things you can implement immediately? And if you have a question, stick around, either email me if you're doing this live with me, or excuse me, put it on the sidebar if you're doing this live with me, or email me if you're watching this in a tape session. Finally, since this is our last date together for most of us, I want to leave you with this. As soon as anybody starts telling you to be realistic, those kids can't learn math, those kids don't belong in core, whatever that is, cross that person off your invitation list to making change. They're not a change agent. And they don't see the benefit that these kids can have with good, strong core and intervention instruction. I hope that what we've done over this past couple months has been helpful, and I certainly hope you've walked away with a ton of strategies. Now that my hour is up, I do need to tell you thank you. You're not only spending time in the front line with the students helping them, you're also spending overtime trying to help them out for new strategies. If there's anything I can do to support that, please don't hesitate to call me. But I do want to thank you for that and wish you the best of luck as you make the change in this world. You are the person to do it. Thank you so much.
Wow, Dr. Witzel, thank you. What a poignant ending to a very engaging series. Thank you for sharing all of the connections to research and for giving us a variety of practical, hands-on, evidence-based strategies that will help to improve student access to more complex secondary math concepts. We are very grateful for all of the ideas and examples you have shared today and throughout the series. Based on participant feedback and the results from our earlier surveys, this series has truly helped to connect the dots from establishing number sense through algebraic reasoning for many of our participants. And I, for one, am ending this series with many more tools in my toolbox to more explicitly teach mathematics to struggling learners. So thank you. Again, my name is Jill Marshall, and I am the SLD Specialist in the Exceptional Student Services Unit of the Colorado Department of Education. Please feel free to contact me at any time with additional questions or feedback. Once the webinar recordings have been captioned, they will be posted on the CDE SLD website listed on this slide. Please consider visiting our website for other archived professional learning events and resources. Also, check back in August for future learning opportunities for educators who support students with learning disabilities. The following few slides will provide some additional resources as well as the evaluation link for this webinar. The link will also be sent to the email address that participants listed during registration. After you complete the evaluation survey, you will be provided your certificate of attendance.